Hi folks, this is activity XX00. It involves creating this gear train, animating it, and then putting some physics into it. Now, to make your job easier, I've made all the three gears identical and the dimensions are given so that it makes it easier to put the whole thing together. Okay? Let's not worry about the physics right now. We're just going to create the parts and I'm going to start with the product file. Immediately save this thing file, save management, save as. I have a folder on my desktop called uh, week 5 activity XX00. So everything is going to go into that folder. Let's see now. I'm in the assembly design. So let me insert my first part, which is going to be the gear. So insert a new part in there. I'm going to call this thing gear. The three gears are identical. I'll just make one and then create instances of it or insert existing components. Okay, let's make it. Double click on it. On a convenient plane, on that vertical plane, I will sketch. I'll sketch this shape with an axis here, an axis defined so that when I shaft it, immediately becomes a 3D object. So here's an axis. You can see that right there to make there. And then the profile is going to be like this. The actual size doesn't matter right now. We can make dimensions in just a minute. Zoom in. Okay, what do we got here? This one is 5 millimeters. This is 20. 20. The distance from here, the distance from here to here is 10. That angle, let me look at this thing directly from above. So the dimension for between this and this, that's 45 degrees. Okay. And this side is 30. 30. Okay, that takes care of the cross section. And I'm going to shaft this thing because there was an axis defined there. Immediately it turns into my gear. Now all the way to the top. Oh, before I go and make the wall, let me make a point on this circle because later on I want to plot the velocity, angular velocity of that gear on the right. So I need to create a speed acceleration sensor. To do that, I need a point here. So I'm going to make it on a curve, and it doesn't matter where on the curve. This blue one tells you where. It really doesn't matter. There, it's going to create that. So we go all the way to the top, save this. Now we're going to insert the wall. Insert, insert a new part in there. And I'm going to call this thing the wall properties wall. Okay. And it's easy for me if I drew it on this horizontal plane that you see there. So let me double click on the wall to go into part design. On that horizontal plane, I will sketch. Okay. So the wall is basically what you see here is something like that, like a C. Let me. This doesn't bother me. It can stay there. We can remove it if needed. So I'm going to go like so, and we will clean it up in a minute. Okay. So first of all, this inner dimension is 120 millimeters based on the drawing that's given to you. And I'm going to make these two about 90. Of course, the location of the shaft is not at the very end. It's some 60 millimeters away, but I'm going to make these things 90. Same thing here, 90. Good. And let's make it symmetric. This control, that line, control the middle axis. We make it symmetric. Yep, that's good. Now the rest of this on the outside, the size of it doesn't matter, so I just go and draw something kind of arbitrarily. Yeah, but I will make it look nicer by making it symmetric with respect to. Okay, good. Let me get this last thing that I did. Last one I'm gonna delete. All right, so left line control, right line control the middle axis, symmetric for visual purposes. Okay, and that's pretty much it. Exit, and we're going to pad it by, let's say, 60 millimeter or 40 millimeters will do. 40. Okay, good. Now on that horizontal, on that plane, I'm going to draw. I'm going to draw a circle that size. It's very easy for me because I can project this. Okay, so let me on that face. I'm going to draw, and to make my job easier, I'm just going to project that. Think that is at the right spot, or maybe. Maybe it's easier if I drew it. So I'll just draw circle of diameter 10, or radius 5. And you know what? We're going to make it halfway between the top and the bottom. So left line control, right line control the center. We're going to make it equidistant. I don't think I selected that. This control that, control the center. Now we're going to make it equidistant. Yeah. Or I could have made dimension 20 millimeters. And exit, we're going to pocket that. That's good. Then we're going to make holes on this side. So on that face, I will sketch. Okay, just to make sure I know what I'm doing, I'm going to change the rendering here to wireframe. Okay. And if this is bothering me, I can hide it. Yep. So the circle is going to be somewhere here, exactly halfway between the left and the right. Left control, what is that? Control right, control center, equidistant. Okay, and the distance from that end to here is 60. That dimension is given to you in the drawing. It should be 60. Okay, exit. Let me change the rendering here. Where is it? Right there. Let me make it pocket. Pocket. And let me make this thing longer because I'm going to make it symmetric so it goes through the other side too. Good. There we are. Okay, all the way to the top. Save everything. Now, when it comes to the other two gears, either I can do instantiation, okay, which is we can get the icon. I don't know, maybe toolbar. It's not there, so we can get it. But the other option is just insert existing component. Let me go ahead and do that. So insert existing component in that uh, product. Now, am I in the right spot here? Yep, gear. I've got to do this thing twice because already there is one here. You can see that it's sitting on top of the other one. And then another one, insert existing component in there. And once again, gear, and they're sitting, all three of them sitting on top of each other. So we can move these things, let's say translate in the X direction like that. And we are good. Okay, good. Now let's go ahead and assemble. So we will anchor the wall right there. A coincidence between this axis and that axis. And you know what? Let me do between these two first. So Control Z. Okay, let's try it again. A coincidence between this guy and that guy, and coincidence between this plane and that plane. And if it doesn't look good, we're going to update it. Yeah, obviously that doesn't look good. Did it mean flipping the direction of those arrows? That's good. Yep. I don't think I anchored. I forgot to anchor the wall. Let's do it again. Coincidence between this axis and that axis, and coincidence between, say, this plane and that plane. Okay, good. I noticed that because of my dimension, these are touching. This is important because later on, I want to do a roll curve joint between these two curves. That is very important. So coincidence between this axis and that axis, and coincidence between this plane and that plane. Flip it, update it. Good. Okay, we are in good shape. We go all the way to the top, save everything. Okay, so let's go to our digital mockup. Start digital mockup DMU kinematics. Okay, get the magic wand out. New mechanism. Auto create. You say okay. So what happens is that we're going to get three revolute joints. Probably degree of freedom is of course 3. Now uh, we're going to create a gear joint between the first two revolutes. So here is a gear joint. You can see that gear joint. It says, okay, between two revolutes. So I'm going to use this revolute, and I'm going to use the second revolute. And for the ratio, if obviously this gear ratio is 1, but if not, then you click on the define and select these two arcs. You see that it'll come back with 1. Okay? So it's not a big deal. Cancel that. This was correct. And they go in opposite directions. And then we say okay. Now, we also need, notice that uh, this revolute joint got gobbled up by the gear joint. So I can make another one and then create a gear joint between that revolute joint that I make it and this one that's still sitting there, or these roll on each other. So why don't I do a roll curve joint instead? A roll curve joint between either this arc and that arc, okay? And then we say okay, or we can do these two because they're touching each other. Point curve joint, when you do point curve joint, the point must be on the curve. When you do roll curve joint, the two curves must be touching, tangent to each other. Slide curve joint, still the same thing, okay? And so, all right. Degree of freedom is 1, no problem. So uh, this, this gear joint, we can make it uh, angle driven, and we say okay, mechanism can be simulated. The only thing that's bothering me here is the direction of the rotation. So these are okay, they're going opposite, but this also should go in opposite direction. So let's check to make sure it's correct. Oh, let me this goes between, okay, so Usually I put it between 0 and 360. That's fine. Let's check it out. Okay, let me reset this. Go back to the gear joint that I made angle driven. Make this thing 0 so that I have a better control of what I'm seeing. Okay, so when I move this, let me do it like this. When I move this, notice that this gear and that gear go in opposite direction. And these also should go in opposite direction. If they do, that's exactly correct. That is correct. You can see that. Reset. Good. Now, so we created a cartoon. I can go and create a simulation and everything, but I want to put some physics into this thing. Actually, let's create a simulation, because if you're going to plot, for example, traces and things like that, then you need that simulation. So I drag this thing all the way in. I insert, rewind, and anything but one, and play it continuously. Okay, that's correct. All right. Now, why do I need to create a simulation in the event that you want to create a trace and everything? I don't want to do that. Now, let's put some physics into this thing. So what's the physics? How does that fit? First of all, let's click on f of x. Click on f of x. Click on the mechanism. This is the speed, the angular speed of that uh, uh, gear joint, basically. So add a formula equal to, if it's a 60 RPM, so that's going to be 360 degrees per second, per second, times time, right? 60 RPM is 1 cycle per second, which means 360 degrees per second, times time. Okay, good. Now let's create a sensor here. In other words, we're going to find a angular velocity of this point. It better be also 60 RPM. In fact, all three of them are 60 RPM because of the fact that they're the same size. But anyway, speed acceleration, reference product is the base, and the point that we want to trace is this point, because this is the one that's driving. All right, good. So now we're going to go to simulation with laws. Simulation with laws. Let's do it over a 2-second interval. So that thing goes twice, basically. I'll do it over a 2-second interval. Activate sensor. So the sensor that I created was for this guy, and I'm going to do the angular speed of it, angular speed of that point. Okay. Move this thing out of the way. I better come up with 60 RPM. Okay. Play it twice. Play it over a 2-second interval. You can see that 60 RPM. Okay. If I had, for example, plotted the other guys, for example, if I had created the sensor at this location or that location, it would have done the same thing. Okay. So now keep in mind, for the purpose, let me rewind this thing, clear the history, play it again. When it finishes, graphics, or maybe it's already there. Actually, the window must be somewhere. Oh, right there. That's why. Is it there? Store. Okay, good. Now remember, this you have to give me on the test. So you know how to do that? You're going to go to control, print screen, or whatever method you know. For me, it's function print screen. I capture this. Notice that I can read the scale. I can read the units. And I go to my, for example, Word document, a Word document. Paste. File, Save As, Browse, Desktop, in that folder, which was, let me see, mechanism, this activities, the instructor asked for this plot and any other plots. You have to capture the image, paste it somewhere, put it in that folder that you're going to submit as your work. Okay, so you can get rid of this because there's no way for me to know whether you have done this thing or not. Okay, besides that capturing thing. Let's go and check it out. I have a folder here, week 5 mechanisms. This was the example we were doing. This was my product. This was my gear because I did use instances of it. I have a single gear, one gear, 2 instances of it were used. There's a wall. There is here, and this is the Word document with that plot in it. Okay, folks,